Hello, everyone. Welcome to this week's binary episode of the Day Zero podcast. I'm Spectre, with me is Z. In today's episode, we have some MTE discussion, a PDF RCE that was exploited in the wild, and more. And we'll lead off, though, with mentioning that the Hexacon talks are out, which is very nice surprise. I didn't expect them to be out quite this early. So for those not aware, Hexacon is a bit of a newer conference. I believe this is their second year running. But it runs in Paris in France, and they usually have a lot of really cool presenters and talks, mainly low level focus, which is why we're covering it today. I've actually checked out one or two of the talks from Hexacon. I checked out the HVCI hypervisor force code integrity talk. They talked about a bypass there. So, yeah, there's some cool talks in there. As usual, there's some iOS stuff as well for those that like more of the Apple type topics, which is nice to get information on because as the years have gone by, information on Apple and mobile in general has just gotten more and more scarce. So there's definitely a few talks in there that will be interesting to you, I'm sure. So yeah, we wanted to shout them out that they're there and to check them out. We might do some coverage streams on them. I forget if I think we did do coverage streams on Hexacon last year. So we'll let you guys know if we decide to do that. But
I'm not sure
yeah,
if we did. We
I'm
did
almost
cover
positive we
some,
did.
but yeah,
Yeah.
I know we covered some from another conference, like because we did the DEF CON, which we haven't done for this year yet. So that's something we should probably discuss too. But yeah, I don't remember what that other conference was. It might have been Hexacon, but I feel like it might have been something else too, because I think we were kind of up in the air over whether or not we could do Hexacon, like given their release license. I'm not sure if they put these out under a I don't see any license information, so um we'd have to check in with the organizers on whether or not we could restream them and do like that commentary stream.
Yeah. So we'll let you guys know as always if we do some coverage streams on them.
Yeah, unfortunately I can't recommend any of the talks because I was like completely unaware Hexacon was even going on, to be honest, and saw this drop and haven't had a chance to take a look at anything. But given last year's talks, I kind of just expect Hexacon to be a pretty solid conference. So I am looking forward to getting a chance to look at some of these.
Yeah. In other news, though, something else that was getting some discussion was Google Project Zero put out a post about MTE titled "The First Handset with MTE on the Market" by Mark Brand. And basically, what it's talking about is that the Pixel 8 and Pixel 8 Pro has shipped with hardware support for MTE, though it's not enabled in software by default, but you can enable it in software, which is what this post effectively goes through. They try out enabling MTE in user space via the Android Debug Bridge or ADB, and they wrote and deployed a test application that just did a straightforward use after free in the string from JNI routine, which you get in the JNI default project, and it will just free a duplicated string and then return it. And they were able to trigger an MTE induced crash with it. So good, getting a little bit into MTE because I'm kind of just saying it, assuming that everyone knows what I'm talking about. It's been a little bit, I think, since we've talked about it on the show, but it stands for memory tagging extensions. The whole idea there is that pointers have a 4-bit tag that is encoded inside of the pointer, and the CPU will do a check on the tag on every memory access. So if you go to read an address or something or write to an address, it'll check the pointer tag, make sure that there's a tag space that's maintained separately. It'll check the tag in the pointer against the tag space to make sure it matches, and only then will the access be allowed. Otherwise, depending on what mode it's in, because there's two different modes, there's synchronous mode and async. In synchronous mode, it will immediately throw an exception if the tag doesn't match. In asynchronous mode, it will set a flag in the CPU that will eventually cause it to throw an exception at some later point. So that's basically what MTE is. It's a pretty strong memory corruption mitigation, which is why there's so much hype built up around it. It's why Project Zero is excited about it.
It's
Um,
strong, but it is probabilistic. So like you only have what is like 16 different possible tags.
yeah, you have
So
an
like
entropy of 16 different tags in the space, yeah.
yeah, so it kind of has that basis on it. It has the potential to be rather strong. And even 16, like a 1 in 16 chance, or I guess technically a 15 out of 16 chance of actually catching something is, quite good. So I
It's a
can't
fairly big
really,
reliability hit at the very
yeah.
least.
And so, like, just in terms of the crashes, or I guess, um, the exceptions it may be to raise during, uh, like, when you enable this, it'll be interesting if they ever do bring it as like something that is on by default. It has, we've talked about before, it has the performance hit, it obviously has and because of that, it's going to have the battery life hit, which, kind of leaves me wary as to when it's going to do it. But it is kind of an interesting option to have it on consumer devices and running this sort of sanitizer all the time, because that could, um, like, in effect, it's similar to just getting a lot of fuzz cases, although obviously people aren't going to be running intended fuzz cases. They're going to be doing more normal things on their phone. But if it's just on by default, there's a potential to scale up and catch a lot of bugs that way, just on accident, by the fact that it's running across so many phones, if they were to ever do that. But it still feels a little bit unlikely given the downsides of it, that they are going to be running it by default. But as something to enable, in terms of like locking down your device, if you're concerned about the security of your own device, like, that is a fair thing to consider too. Uh, just because it will impact a lot of exploits. A lot of exploits either won't be written considering MTE, or will have to take extra steps to detect MTE, and then, like, even trying to do that could potentially result in triggering MTE just with their initial, whatever the initial exploit's doing, before they can kind of do any sort of background gathering on on the target that they've actually landed on for. Assuming a remote exploit, local exploit, you can obviously find out that a lot easier. Um,
That's a
but
fair point that I
it's
hadn't thought about actually. The potential to burn more like in the wild exploits, just in nature of like potentially not being able to probe if it's present. It's something I hadn't thought of, but very valid.
yeah, like, on the remote side, especially, it could definitely catch some of those a lot more. With all the downsides again. So we'll see how that actually comes. One thing that came up in our Discord, I think this was a couple of days ago, but Binary Zero had asked, do you guys think the demand of VR skill will increase in coming years? And then goes on to kind of quote Project Zero post here that we're looking at about MTE being added there to detect memory corruption exploits. And I guess that kind of comes down, like, the question is, the demand for VR skill will increase, and in a sense, VR isn't exactly hit by this because the vulnerability still exists regardless of MTE. MTE is really going to be the impact on the exploit side, but I feel like they're probably asking about both VR and exploit dev, and I'm just maybe being overly technical about it.
I mean, it's a fair distinction, but the way I look at it is if MTE is able to kill certain bug classes, then your VR is gonna like you're gonna have to be looking for more useful
Different
bugs. So
issues, yeah.
it kind of impacts the VR still, yeah.
Yeah, I guess in the same way something like NX and ASLR did too, where it kind of changed the meta, where you're maybe not doing these one-shot exploits with, stack pointer override. I think a similar kind of dynamic will come out of this. It will change the exploitation, and MTE has a pretty wide impact. Just because it won't do a lot when it comes to like an intra-object overflow. So you're overflowing, just corrupting inside of one, like, keep allocation, one object. That should all have the same tag. But it will do anything when you try and go to like the next object, because I'm not sure if the Linux implementation is intentionally doing this or if it's a purely random tag that they're assigning. But an easy win is just to make sure, like, two blocks side by side don't have the same tag. I say it's an easy win, but that might be a little bit more difficult in practice. Uh, just given like hole filling and stuff, could make that slightly more tricky to do. But making sure two adjacent blocks don't have the same tag would make it hard to get any sort of overflow that will cross heap allocations, which a lot of exploits take advantage of overflowing into that adjacent block. Out of bounds rights maybe have a bit more of a chance. And I guess we have talked about issues with MTE before. I should have pulled up what episode. Do you happen to have that handy when we've talked about like or issues the security analysis of MTE? It was a
I
Project Zero
don't know.
post not super long ago. So
Yeah, I can try to do a quick look for it, but I don't have it on
well,
hand.
we're sitting here on like the Project Zero. Yeah, right here. MTE has implemented part 1, 2, and 3.
Ah,
Interesting that
right.
they're
Yeah, that
actually
wasn't
out
even
of
that long
order.
ago.
Yeah, it wasn't. Like we covered it super recently. There was also a Linux con. Was it the Linux? One of the Linux conference. It was a
I think it
conference
was the
about
Linux
Linux.
Security Summit.
Yeah, that's what it was. There's also that presentation which kind of covered how they were actively implementing MT and gives a lot of details there too. Was that Andrei Konolov?
Yeah, it was. Yeah.
Yeah. Sorry, I don't have the link. If I remember, I'll try and add it to the show notes. But otherwise, you can look him up and find this memory tagging post from the Linux Security Summit.
Yeah,
Because
and
that gives
in
another good
that
overview.
yeah, in that presentation, he goes through some of the weaknesses of MTE, including the intra-object overflows as well as the granularity, because it's only granular to 16 bytes. But yeah, and what you mentioned about the allocator, like in Linux, it's funny because I went looking recently to try to find some of that because someone asked me like how MTE works, like what does the tagging specifically, and that is done at the allocator level. So yeah, in theory, you could do something to try to make sure that adjacent blocks don't have the same tag, but I didn't look deep enough to see if it actually does do that. Although even that, like that would come with a slight downside, like it's minimal in like in the grand scheme of things, but you would be reducing your tag space even further then, because then you're reducing from 16 potential tags to 15. But um, yeah, it
Well,
is.
15 or 14 because both sides of any
Yeah,
block. Although you could technically match and do like a, red black just alternate them. I mean, the thing is that does offer protection against that linear overflow into the next block, and that there's no chance that you're ever going to have that situation. So I think that drop would be worth it. Because
could be
especially with
significant perf overhead though on that too.
I'm not sure how I mean you do have to do the lookup like the indirection on both sides. I don't know. I'm definitely not the first person to come up with that idea, so they might even already be doing it. Like it's something that I've heard spoken about elsewhere as a method to go forward on it. I'm not sure if it is actively being done. Uh, Kind of jumping back onto that question though. It has the potential to do a lot, but I think it's mostly just going to be kind of as usual. These different mitigations tend to add layers onto the exploitation, making it a bit more difficult, meaning that maybe you have to look for a different type of bug. Maybe you have to be either aware of that and look for different exploitation strategies. But, just hacking culture in general, people are going to find a way to break through things. There are weaknesses in here. That is something actually the Project Zero post about MT has implemented kind of talks about like kind of big picture issues. They also actually talk about some specific considerations, but it'll make things harder. But that's just kind of part of the growth. And I mean, exploit dev on a whole, like if you compare getting started with like this binary level exploitation today, like doing that vulnerability research and exploit dev at the binary level right now, and compare that to how like the web has grown over the years. Like web has gotten more complicated in terms of breadth. Like there's a ton more vulnerabilities, but you're still able to exploit a lot of those old issues. Whereas even if you wanted to like compile a binary to be vulnerable to like the same issue we had 20 years ago or something, compilers aren't even going to let you do some of those things anymore, um, or make it exceptionally difficult to do. Like even some of those old straightforward overflows, like compilers will now reorder things on the stack, making it less likely that your buffer is going to be able to overflow into something useful. I mean, arguably, because it's they basically just use the size of the items as a means of structuring and as it may as kind of indicating what is likely to be to overflow or not. So it's not like a perfect thing, but it adds those limitations and just there already are those steps, so it's just another step being add on. Yes, it'll be harder. It'll make O days more difficult for sure. But I don't think it's going to be the end of like exploitation at all or something. Because I mean,
One.
Go ahead.
One thing, for example, that I think MTE will do is it will put more value into info disclosures, because you might be in some situations where you're going to be forging pointers and you would need to know the tag for whatever you want to forge. So, in order to get that tag, you would want an information disclosure to find some legitimate pointers or whatever to disclose the tag. So, I could see info disclosures becoming more relevant. I mean, they're already pretty relevant in modern targets, but even more so. I could see them being
Yeah,
maybe
like
required where they weren't before, where you could kind of use tricks to get around things like ASLR. Maybe now you would need more of an info disclosure in some of those scenarios.
yeah, partial overwrites kind of come to mind as another option too. Just using kind of that sort of route. I'm not sure about the practicality here with MT because I haven't really played around with this at all. But that feels like the sort of thing. If you can leave a tag unchanged, could you? Well, I guess even if you leave a tag unchanged, that doesn't actually help you all that much because if you're changing the pointer, you're probably changing where the tag needs to be. So, actually, yeah, maybe that's not super relevant. But yeah, information disclosure, especially as right now, a lot of the information disclosure is just like leak a code pointer anywhere and then you use that like the ASLR bypass, just figure out the offset. Whereas this is like you need the point or the tag for a very specific thing.
Yeah, you need a better leak. You need a more specific leak.
And thank you, Chip8, for the Prime sub. Um, yeah, you need a more specific leak with that. So actually I think might change the dynamic of info leaks in general because a lot of info leaks are focused on getting those code pointers out, not I mean people definitely find things that'll leak the heap and stuff, but yeah, that is definitely an interesting aspect to it. I feel like on a whole, if anybody's watched our like I think that that was some like binary exploitation 2021 and beyond or something like that. I do feel a lot more optimistic having seen both MT. I mean, we kind of saw more details about it after that post was written, along with Intel CET. Both were kind of looming in like the near future at the time we did that. I think we were both pretty pessimistic about kind of the future. And I mean, I was still, talking 20, 30 years out, but I do feel a lot more optimistic seeing how these things have come and where people have taken them already. So, I mean, it'll make things harder, but we're still going to be around.
I think it might just shift the, like, tying it back to Vuln research specifically. I think it's just gonna shift the meta of what kind of bugs you're looking for and which kind of bugs have value. I don't think it's really gonna make it significantly harder in and of itself. It's just gonna change how you assess the exploitability of different bugs, basically. I do want to jump back a little bit because one of the things that's significant is, like I said at the top of the discussion here, this is being enabled manually after the fact. It's not enabled by default. And this post is pretty short as far as P0 posts go. I wish they did a little bit more testing and benchmarking in regards to performance and battery life. Z kind of mentioned it, but I think that is a pretty important thing because I'm really curious not only what the performance overhead looks like for sync and async mode of MTE, but also what the power draw is like. Because if it's significant, I don't think it's being enabled on really any consumer device because I don't think general consumers are going to be willing to give up significant battery life for a mitigation that they can barely understand or appreciate. So I'm curious on that. If the power draw and perf overhead are as significant as I think they might be, I don't think MTE will be used a lot, though I don't think it'll be dead completely for mobile in its current form. What I could see happening is maybe locking it behind some kind of mode, sort of like how iOS has their lockdown mode, where if you're an entity that's at a higher risk for being targeted, or you're going someplace that you think makes it more likely you'll be targeted, you can kind of flip it on, have MTE going for that duration of time or whatever, and then flip it back off. I think that seems more likely to be practical. Um, so I wouldn't be surprised if it goes in that direction. But yeah, I do want to see some, because there's basically no public information at all that I can find on the hard data of what the perf and power draw demands are. I believe in the presentation that Andre gave that we mentioned earlier, he gave some hypothetical numbers of like 10 to 20%, I want to say. I think that was on the sync mode. But those were like theoretical. We don't really have like hard numbers, and that's sort of expected. It's a new thing. There's very few devices that shipped with MTE. One thing that was kind of weird was the title of this was the first handset with MTE on the market. I feel like Samsung or someone had put out some phones this year that had MTE support in the hardware as well, but maybe I'm wrong on that. But anyways, where the hardware is so limited as of yet for getting your hands on MTE, it kind of makes sense that that data isn't there. But I think we should be trying to get that data because, like I said, ultimately, if the power draws too much, the current form of MTE probably isn't going to be used in many places.
So I'm not sure about Samsung having MTE. I did a quick look and couldn't find anything. And this is a very quick Google as you were just talking. I believe. Oh, actually, I guess this might have been after. Yeah, sorry, this isn't as old of a post as I thought from the search engine giving me a date. I was going to mention Graphene OS supports, but they run off the Pixel. So yeah, on Pixel 8, Graphene OS was able to get it on. Because I think didn't the Pixel 7 hardware support MTE, and it was just like the kernel version didn't.
I'm
I'd
not
have to
sure.
look into that. Yeah, I don't know offhand if that was the case.
So I kind of remember what I was thinking for Samsung. I believe what it was Samsung kernels had shipped with the config options for MTE, but it might not have been in the hardware at that point. So that might have been where my confusion is coming from on that.
No,
But
okay.
regardless, like it's cool to see MTE coming on actual devices, and it'll be interesting to see what the benchmarking looks like and how much it's actually going to be used. But yeah, as you mentioned earlier, Project Zero does have some other posts that look at MTE, though they're not looking at the performance in terms of like speed or power draw or anything like that. They looked at the how effective it's going to be against various exploit scenarios and whatnot. So if you're interested in that, I would recommend checking out those posts. We did cover them on the show. I don't remember exactly which episode number, but it was pretty recent because those posts were put out over the summer. But yeah,
Yeah,
um,
probably our first
it,
episode back, September 22nd or whatever that was.
yeah.
Uh,
And the other thing I want to say is even if MTE is does turn out to not really be viable to put on many consumer devices, it's still a net benefit because it's going to make security research on these devices easier too, because it is effectively hardware KSAN. Like that is the alternative name for it, and because of that, it's going to lead to be able to like anyone that might be doing on-device fuzzing or anything like that is going to be able to catch issues easier than they would have before. So MTE is going to have value regardless of whether or not it's massively deployed on consumer devices.
of course, then it's
It just
only
remains to
catch.
be seen if that is going to happen.
Yeah, of course, in that case, it's only catching bugs that will definitely trip MTE. Which
Yeah, true.
is still useful, but like, it's catching the bugs that will be caught. You did remind me of something when you mentioned iOS a little bit back, and that is iOS has had pointer tagging for a while, which is, I mean, it's a different usage of tagging the memory by putting a signature on the pointer instead of just using like the standard tags, but you've got some similar problems with it too. And that hasn't killed exploitation. It's not set out in the same way. Like it does stop different types of issues. The focus is definitely different. I just want to shout out, like, iOS has had something kind of similar in a sense for a while that hasn't like broken the world or anything.
Yeah, the pointer authentication. So yeah, it's a good show. All right, so getting into some of the vulnerabilities we have for the week, we have a fun return to console exploitation post on a Wii U exploit that exploits a bug in the DNS client by Gary Otternitz. Apologies if I pronounced the name wrong. And the bug also has a bit of a side door type feel to it. So it exploits a previously known bug, CVE 2020 25928, which was in the infra. It was called infra halt, but it was in the modified version of niche stack. And
Well, so
the
I
bug
thought
is
it was funny because they actually didn't. Well, I mean, they kind of did exploit that, but like the fact that Nintendo patched that issue, uh,
I don't know if they exactly patched it. It's kind
yeah,
of
they
speculated that maybe they did spot a potential problem there, and that's why they rewrote it. But it's like pure speculation there.
Yeah, like their code differs from the niche stack in that one way where they catch, I guess you'll get into the vulnerability, but they catch the case that's vulnerable, or the main case that's vulnerable, and like the really easy, obvious the trigger case that's vulnerable, and they replace it with a not vulnerable call. So it indicates that they seem to have known about the vulnerability. But then, yeah, they leave it. Sorry, I'm kind of jumping ahead a bit, so I'll let you get through that.
No worries. So the code that's relevant here for those who can look at the screen is when they're parsing PTR DNS records or type equals hex C. The problem is, you can see in this original code they call DNC set answer, and when you actually look at DNC set answer, all it does on PTR type records is it'll call memcopy with the record length, and it doesn't do any bounds checking. That length is user controllable, and you can just make it as large as you want. So it's the most basic overflow you can have. But it's a bit interesting because, as he said, it is a little bit different in the Wii U version of that function. Because in the Wii U version, they don't call DNC set answer on type the hex C type. They call DNC copy in, which does implicit bounds checking. The problem is for any like non-hex C type, they use DNC set answer. So that's where you kind of have that side door where it's like, okay, the case that was vulnerable in niche stack vanilla is not vulnerable, but it's basically the same issue in a slightly different area. So pretty straightforward overflow. In the Wii U case, it ends up being a heap overflow in the DNS query struct, of which they can overwrite a few of the additional fields. It's an intra-object overflow.
Yeah, just before
Uh,
you go into all those details, I did actually want to shout out the slightly different area, like where this thing is, where they added the protection is like when you send a query, if you sent a query for the pointer record and you get a pointer, or like you ask for it and you get that back, it won't be vulnerable there. But where it is vulnerable is in the case where a pointer record is included in the additional record. So the DNS server can decide, like, oh, you asked for these things, well, then these other records might be useful to you also. It's not a direct answer, but might be useful for you. So that could be things like including DNS security, something in there, maybe something about the mail server, whatever. Like they can just decide it is somewhat arbitrary what the server will decide to send you, but it can include these other answers that weren't asked for in the response, and it's all of those that are still vulnerable to this. Like if it's sent without being asked for, then it just assumes it's secure. Well, I mean, it doesn't assume it's secure, but it is vulnerable, and will just use that, or will make the same check on it. Which I do find rather interesting. The fact that because it's not like these two things are very far apart in code. If they're aware that DNC set answer is vulnerable with the C case, then it's like, why wouldn't they make that extension to like the else block? I mean, I guess part of this is like they're cleaning up the code here to make it really obvious. Perhaps there is a lot of lines that are being commented out that, you can kind of miss that connection, but I don't know, it does feel weird that they only patch the one location for it. But yeah, I just wanted to shout out kind of that additional case where it's basically these are unasked for records that you then get access to the same function call through.
that's a good catch. I did kind of skip over the fact that it was on the additional records that are attached to it. So yeah. Um, So it's a bit of a weird case though when it came to exploiting it because the networking stack on the Wii U runs on an ARM processor, but the Wii U's main CPU is PowerPC. So that DNS query struct ends up getting copied back to the PPC side using a pointer from the reply structure, which is pointed to by that DNS query's object. But it's difficult to spoof because you don't have solid information on the heap state to find any data that you could set up to spoof the reply structure. And the way they got around that was abusing DNS over TCP, which the Wii U supports. And it's a mode that'll fall back on after 2 attempts of using UDP fails, and if the truncated flag is set in the DNS header. And the reason this ends up being interesting is DNS over TCP adds some additional fields to that query struct, including a pointer to where the received TCP data is. And notably, you can point that to a predictable address at the start of the heap where pre-allocated packet buffers are stored. So now you have a situation where you have arbitrary data that you can receive to a known address, which can allow you to fake that reply structure, which contains a pointer to the reply buffer, which you can hijack as an attacker to get the query structure effectively copied anywhere that you want. And that includes 256 bytes of completely controlled data, which is more than enough to create a ROP chain. You just copy it over the stack and you can pop the Wii U kernel. So pretty cool how it was taken advantage of there. It is taking some liberties with the fact that, you're in 32-bit and you have sort of a more predictable address space. Um,
I'm not sure if there
but
even was ASLR on here either, because they're talking about early
yeah,
things being like at the same place on the stack. I'm even assuming no ASLR.
yeah, it's
Um,
just that the heap is unpredictable in nature, so that's why they had to go the extra
yeah,
step. But yeah,
yeah, but like they didn't have to. They were able to reuse that one earlier buff, so like they didn't have to use it when there wasn't enough entropy on the heap. Is more what I'm getting at. They did also have an interesting constraint on this exploit that I think you kind of skipped over, and that is with that TCP receive buffer. Before it started writing to it, it would actually call this iOS heap realloc. And that's just like the operating system running on this ARM core is iOS U, not related to the iPhone at all. The Wii U did not have an embedded iPhone. Um, so it was basically it's a realloc call. So resize the pointer or get another block with it could potentially return another pointer of the appropriate size if it needs to, or it can reuse that block. Um, and that kind of created the interesting constraint on in terms of reusing it, just they have this heap overflow, but in this case, I guess it's not so much of a constraint, but basically, they couldn't overflow that other block with this right that they'd gained. They had to reuse a block that was of the appropriate size to what they were also going to write to it. Otherwise, it would reallocate and send the pointer off somewhere else instead of reusing the block. So I thought that was just like an interesting thing to need to keep in mind with this exploit that they could hijack already allocated blocks, but in hijacking them, they couldn't overflow them. It would do the bounds check in a sense on it. Didn't make a huge difference here. It's like they're reusing the one buffer and they're not intending to overflow it. I just thought that was kind of an interesting aspect to it.
there's a
Actually,
fair amount of cool quirks to this exploit chain.
work is a good way of putting it. Yeah, and the fact that it was off the co-processor and then kind of attacking the main processor is kind of a fun aspect of this too.
Yeah, you don't see that too often. At least not outside of more like IoT type stuff, maybe. So
I mean, even a lot of the IoT stuff we've covered, you don't really see that. Like, I'm not sure if we've ever covered an exploit. Well, we've covered some that have gone GPU, from running on the GPU and then attacking the host or that way. Um, but nothing quite like this.
yeah. So moving into a bit more of a malicious vulnerability, there was an in the wild post by Project Zero that talks about an Adobe Acrobat PDF reader RCE, and I'll let Z get into this one.
Yeah, and this one, right off the bat, this was they found this set in the wild. It was part of an exploit chain. They do actually include some of the exploit chain here, but this bug was used by government-backed actors in North Korea as a way of getting RC with an Adobe Reader, and this was part of some attacks going for security researchers again, which I think this is now like the third time we've seen a North Korean campaign targeting security researchers. And
There's always another sequel.
yeah, and there's a whole post about that if you're interested about that aspect of it, from Google's threat analysis group. But as for the vulnerability itself, it's nothing too crazy. I actually thought some of the other parts of this post were more interesting. The whole bug comes down to this SFAC get S bitmap. Uh, Effectively, actually, I should be looking at the actual vulnerable code instead of the patch, but basically just doesn't do bounce check. So inside of this, the code will end up merging glyphs as it's reading the true type font, and potentially running into the right scenario, it's going to merge glyphs together. And in merging the glyphs together, it doesn't validate the X and Y position. So you basically calculate the index, grabs the Y off. In this example, they've got the code here, grabbing the Y offset. It just doesn't validate that that is still going to be within the constraints of the actual array that's going to be accessing. And so uses this index, accesses the bitmap, goes out of bounds on the bitmap, and writes out the new glyph there, I believe. Um, Patch was, of course, adding it. Like, I don't know, I don't find the bug itself super interesting, just because it is pretty simple. Lack a bound check on the actual array offsets. They do talk a little bit about the exploit strategy. One thing, no, kind of working out here, it's generally pretty standard. Spray array buffer, array objects, load your malicious font, corrupt the length field of one of the array buffers, then you can iterate over all of the array buffers that you allocated, find the one that has like a new length, which gives you some local read-write primitive, overwrite the adjacent length in one of the array buffers nearby, then you get your arbitrary, you can set up the adder up primitive, which you
Just to
see a
be
lot
clear,
in thread.
there.
Yeah, go
Sorry,
ahead.
just to be clear though, those are eScript objects. So it uses the same terminology as like JavaScript, and it's very similar in the types of objects that are being used here. But that's kind of where it's coming from, is from the eScript object. So that's why you have the array buffer and these very nice attacker-friendly primitives to go with.
Yeah, and I was
So
just going
like
to
you were gonna
mention,
say
like,
there, it's very similar to browser exploitation. Yeah.
yeah, the whole setup there. One part I was going to call it here is this: the exploit we found in the wild did deal with a control flow guard. So CFGs on Windows is their control flow guard. It is only a forward edge guard. So their bypass here is relatively simple. If you're not using, or if you don't have CFG, the exploit will simply overwrite text size in the v table of a text box and then trigger that call. Makes sense, or basically overwrite a function pointer of the v table. Seen that a ton of times. If you were on CFG, it'll leak the stack address and just overwrite return pointers and do a ROP chain from there. Because CFG on Windows is only a forward edge protection, it does not protect against ROP, so you can just corrupt the stack and go on from there.
I
Presumably, it
find
didn't
it
deal with CET, which does the backward edge.
I find it interesting they even have the two different routes though. Like, why not just assume that CFG is present and only go with the ROP route? There
So
must be some drawback to it where it's not as reliable or something.
if I had to guess, yeah, that was kind of my thought, is reliability, because whenever I'm thinking about sniping the stack address, like, or the return pointer on the stack, it always feels like this really precise, like you've got to hit the bullseye on it and know exactly what that layout's going to look like, um, in order to have it, return predictably. So any sort of offset differences, like there's a lot that can go wrong with trying to snipe data on the stack. Whereas, V table is a lot more consistent.
On
Some
the other hand,
stack,
though, like the stack, as long as you time it properly and everything, like you don't really have parallelism. So you should be able to, well, even if you did, I mean, each thread would have a separate stack anyway. So, like, the stack should be fairly predictable. It should be reliable enough, I would think, but
it
maybe I'm
should
just
be. I don't
forgetting
know.
something.
That's always just been the general feeling of mine, is when you're trying to get that very, I mean, in a sense, like you're doing a very precise override too when you're going for the specific element of a V table. So it's technically not different, but I don't know. The stack route feels different to me. Maybe just because, maybe it's a slightly different build when they're exploiting it. Maybe things change. Maybe alignment
That's
change.
more, that's a
Like,
fair point. The stack can change, like the stack layout can change quite a bit between different compiled versions. That might be it, yeah.
yeah. So that would be my guess. Is they just felt like it's too precise. Like, even if you did something like you scan for what looks like a return address and like your expected return address, even that, can get confused potentially on other data. So yeah, I don't know. My strong assumption is that they just don't want to. They want to go with the more predictable route. Um, so want to at least call out that bypass is something, because we don't usually get to kind of see both routes. Um, where was the other thing? They did talk about how they felt this might have been discovered, and they brought up one interesting aspect. So their suggestions for how this bug could have been found was one, just smart fuzzing TTF or true type fonts against libcool type, which is the one shipped here with Adobe Reader. Fair enough. Generate a bunch of true type fonts and just see what crashes come out of it. It's kind of a standard way of going about it. The third one they have is code auditing. Just look at the code and audit it. Again, fair enough. binary diffing the various library forks, that was an interesting approach on this. It's basically what they're saying is that TrueType, both from Microsoft and this CoolType library from Adobe, they both share kind of the same SBIT and SFAC functions. Which means if you did binary diffing, you can look like, hey, SBIT in this one does something a little bit different than in the other one. You kind of do that differential aspect to and use that discrepancy to be like, is there a vulnerability here? And I've talked about that a little bit, and just in terms of general vulnerability research, where you learn one technology stack or like one technology protocol or whatever really well, and then you look at several implementations and see what they're doing different. This is taking that to a little bit of a different level, but I like this idea. I don't think I've really gone this route. Usually with diffing, it's like patch diffing in my mind. Uh, but doing it in this way, I think is a really good idea. At least when you've got that case and you're just looking for the bugs in general versus having a really specific target. I think it's a really good idea.
Yeah, we've seen it talked about and touched on before a bit with like differential fuzzing, but not so much on the manual side.
Well, yeah,
So
differential fuzzing is where you're running the fuzzer and then like against the same library twice, or not the
it's
same
not
library,
quite the
two
same
different,
thing, but
yeah, two different libraries, and you're comparing the outputs. And yeah, at this level, it feels different, and I think it's a really good idea. Maybe everybody's already been onto that, but I've overlooked it.
I agree. I also will say it's a little bit interesting to see like in the wild exploitation with North Korea targeting researchers with this. Um, I mean, I guess researchers are opening PDFs for like documents and stuff, but how often are they opening untrusted PDFs? Like, it seems a bit of a weird target, like
Well,
selection, I guess, in terms of their exploit strategy or the targets they're looking at.
yes
But
and no. I mean, because this was, I didn't actually give the tag post a read. Let me I mean the link. Okay, here's the link. But I assume this is like the past ones where they would get to know somebody, like talk to them on Twitter. Yeah, they do have Twitter here. And like it had a bit more of a personal aspect and actually trying to get to know somebody a bit. Apparently,
fair
only
enough. So it could
one
be something
related.
like, hey, I have this document that could help with exploiting this bug or something,
I
like
think it.
documentation or
I
something
think it
like
went
that. I could
deeper than
see.
that. Like this was the case. So one of the last times, uh, they actually one of the past ones, basically, they had several people that would effectively befriend somebody, work and talk about needing to work on something, and then they had like that malicious VS Code thing or whatever. I forget exactly
Yeah.
what the route was, but it seems like there's a bit more of a back and forth and a bit more of an attempt to uh befriend their targets before actually dropping the exploit on it. I mean, they did have that website we covered, that was kind of generally targeting anybody reading the write or the exploit write ups, but outside of that, like it was getting to know or it seemed to be getting to know people a little bit better. So with that, like I could understand somebody opening a PDF in that context, depending on how it's presented. Chip 8 asks, how many researchers actually prefer Adobe software? I definitely don't. I haven't actually ran Reader for quite some time. That's Although I guess I have run like Photoshop and stuff, so that is still some Adobe content. Yeah, I don't know what the stats would be on like who runs what. Uh, I feel like for a lot of people though, like who are well, no, I don't want to make. I was going to make a claim about like more business environments definitely having Adobe or needing Adobe for various reasons, but that's going to depend so much on the person being targeted, and like odds are they're not necessarily doing it on like a work machine that they're also talking about random exploit dev with somebody. Like that is a much more minimal set of people that would be doing so. But I mean, Adobe is the most common thing, and odds are the document could have been a legitimate document. So if they weren't running Adobe, they just weren't hit. Like, assuming it still generally worked, like the document looked right and stuff, you might not even notice failed exploit attempt.
Jumping back a bit, what you mentioned with the like social engineering aspect of it, that's fair. I hadn't really considered that. It had been a while since the North Korea stuff happened. I forgot that they were trying to get more in like personal like DMs and stuff with researchers. In that context, I could see it being more reasonable. So fair enough. And yeah, I
This
mean, with
was
Adobe, I like to use the browsers for PDFs because it's it works well enough and whatnot. But I mean, maybe if you're
browsers.
doing more contract type stuff and you need the additional features that PDF has, then you would use something like Reader. But again, like you had already mentioned, like that's going to be highly specific on the individual. So
Yeah, like I mostly use something else just for the case of needing to sign PDFs.
exactly,
That's
yeah, that's the
the
only
one
case I can think
case.
of where I don't use the browser or I wouldn't use the browser. So
Yeah. Although I will mention this is a newer North Korean campaign. This one was reported on by Tag on September 7th, so just before we came. Actually, I guess 2 months ago, exactly 2 months ago.
yeah.
Whereas the one that we've actually talked about and have a bit more familiarity was like 2 years ago. I feel like I don't
Yeah, it's been a
remember
while.
exactly when that was, but it's been a good chunk of time.
For sure, yeah, that was a few years ago. Because that's when, yeah, we had that bit of fun stuff with YouTube. So yeah. All right, so we can move on to a more interesting bug. So there was actually a few things about this. So there were slides that were put out in Eco Party. That's how I originally saw this. This article though has a little bit more information, and it's on a CPU vulnerability actually. So the name of the presentation was "Smashing the TLB for Fun and Profit," and yeah, so it talks about basically exploiting an issue when it comes to TLBs. So I want to do a bit of background here because if you haven't looked at like low level CPU internals, you probably won't really be able to follow what's going on here. So, in modern CPUs, there's a structure called the translation look-aside buffer, abbreviated the TLBs. And the idea with that is whenever you have to do paging, so when you access an address, right, that's going to be a virtual address typically, that's going to then have to be translated to a physical address, and that has to be looked up through the page tables. That operation is very slow, especially because like you have multiple levels in a page table. Like typically on x86 nowadays, you have like a 4 level page table. Going through page table levels is not something you want to do on every memory access. It's not friendly for performance. So that's where the TLBs come into play. The TLB will basically cache address mappings to try to make lookups a lot faster. That way, you know, if something does change, you would need to flush the TLBs, and that's where you'd have the performance overhead. But generally speaking, if a given area of memory is being accessed frequently, it will be cached in the TLB. So, uh, something that some people might not know though is that while the TLB is typically referred to as one thing, it's actually comprised of multiple caches. So, for example, you'll have the instruction TLB or the iTLB and the data TLB. And part of the reason that they have these different caches is just to reduce contention. That way, you won't be having data accesses interfering with execution and vice versa. But you have to keep those caches in sync. As soon as they have like a desync, you have problems, and then it's made even more complicated because the DTLB, for example, can consist of multiple physical areas on the die that represent the translation look-aside buffer for data.
Yeah,
So
and can
you
I
have a
just
lot of
add,
things that you have to keep in sync.
this
Go ahead.
post talks a little bit about the sync, and it talks about something I didn't know about. But apparently, back in the day on x86, they used to use getting a desync between the iTLB and DTLB as a way of implementing non-executable pages before there was an X bit by basically getting it so only the right data loaded in the DTLB, but the instruction TLB would load bad data and thus wouldn't be able to be executed, which I just thought was really cool. I didn't know about that going on, so the fact they call it out here, like that just sounds like a fun thing to run into.
Yeah, and I'll make a quick mention that this is a little bit specific to PS5, so I won't go into it too much. But for those who aren't aware, the PS5 has execute only memory for x86. As far as I know, it's the only x86 device that has it. And it's believed that this is effectively what implements execute-only memory as well. Is that basically you can't do data fetches to get the addresses into the data TLB, but it is fetchable from the instruction TLB. So yeah, it was kind of funny. Like this is basically what they mentioned here is like the inverse of how we believe execute-only memory works on things like the PS5. So
Oh, that's cool. I didn't realize that.
yeah, we
Yeah,
don't know for
definitely
sure because the TLB
interesting.
is so undocumented and whatnot, which they
Yeah, of
kind of talk about
course.
in this post actually, but it seems most likely. So yeah, like I said, when you're dealing with these TLBs, not only do you have to keep track of a lot and keep everything in sync, if you're not like a chip designer or something, you have to make a lot of assumptions and guesses as to how the TLB actually works, because a lot of the tags and behaviors that happen in various scenarios are not documented. You just won't, like, you'll just have to guess at them unless you are directly involved with implementing those. And even then, like between different chip versions and different chip manufacturers, it's not necessarily going to be standardized, so it's like a huge mess. So the problem here that they named their bug itlb multi-hit. The problem happens when you have an instruction fetch that can hit entries in the instruction TLB for different page sizes. Um, so I believe the direction they went in was going from a larger page size to a smaller page size. And we're like, okay, what happens if you try to change it to a smaller page size? And it turns out that the smaller page size is what's actually used. Um, but yeah, so sorry, Z, you looked into this a little bit more, right? Or you got a better reading of this? So I'll let you take over on that side of it.
Well, yeah, so this was something that I think was better documented uh, in the post rather than the presentation. The presentation, if you watch the YouTube, which is mostly in Spanish, it probably does talk about this in relative detail, but I couldn't get because I don't understand Spanish. Uh, and also, I don't have a good rap on this one anyhow, but basically what they have here is just mentioning that when both the physical address and the page size both get changed at the same time, then you end up in the case where the old TLB entry has to be removed from the instruction TLB for the old page size, and that new entries, multiple new entries because the size is smaller, uh, get poked in or basically get added in also. So when going from the smaller page size to the larger one, they'll end up removing several entries and adding just the one. Um,
Right, sorry, I got the direction wrong. It's going from smaller to larger because, yeah, like you said, then you have um, the number of TLB entries changing.
and they just mentioned certainly in that situation when you're doing that, certainly sounds like things could go wrong, like an entry briefly existing in TLBs for both sizes at the same time. And that is the thing, they don't strongly root cause this bug because this is undocumented hardware issues. They actually speculate that like part of this, like why this becomes an unrecoverable crash, can just be because of electrical corruption when it's expecting like one of these bits to be parity and then it's not because multiple TLB entries are driving the bits. Um, things like that. So there are some questions. They're more speculating about how they think this may have been. And their hypothesis, I'm just going to quote, or hypothesis is that some instruction fetching, at least pre-fetching, can actually continue during this process. That's during the removal thing. Um, and thus you end up in that case where both the iTLB and DTLB, uh, basically, or it exists in both the iTLB and TLB implementations, but only instruction fetches are possible, not data access. Well, no, 100% confirmed. This explanation neatly accounts for all our observations. Sorry for just quoting that, but it's this bug on the whole is definitely a little bit lower level than I'm terribly familiar with.
Yeah, and I will say their speculation that it's corruption at the electrical level. I don't think you went into the specifics of that, but what they are assuming is that the data pins from the different TLBs on the die are connected in parallel. So if if multiple TLBs are trying to drive that same line at the same time, you get really weird physics starting to happen with the electrical signal basically is not predictable. So it's it's about as low level as a bug you can get. I mean, you're getting down to like the physics level at that point. And that's where they think like, if one of those pins is parity and that signal's being corrupted, uh, that could that could trigger the exception. And yeah,
Yeah,
I
and
mean,
the
it's just kind of crazy how low level this bug does go. So
yeah, like it's absolutely or definitely seems to be a CPU bug, not like well, I mean microcode bug perhaps, but they do in the presentation, not in this post, they do talk about their fuzzer and how they actually came across the bug. Um, which I thought was interesting because it is or it sounds like a relatively simple kind of, I mean, somewhat simple fuzzer where basically their VM fuzz. Trying to see if I can find it in here. Yeah, they developed basically the hypervisor fuzzing framework, basic architecture of just having a unikernel that talks to all these external fuzzers, and those external fuzzers can be generated either as like a target specific thing, doing like some specific hypercall or talking to some specific device, or just a generic thing generating, x86 to like, access MSRs, do IO, the low level IO or whatever. Um, the way they talk about it sounds like, somewhat. I mean, I guess we don't have enough details there, and every fuzzer is probably implemented on its own. But it's a fairly simple, at least, overview and architecture for a fuzzer that I'm
yeah, I
not
actually
sure
really
if
like that
VMFuzz is
section.
open source or not.
I don't think it is. I looked for it. I did
Okay.
look for it.
I didn't take a look for it, but it seems like something you could relatively easily copy. Granted, you have the knowledge of actually writing like small kernel and stuff to run and all of that. But I mean, I appreciate that they at least gave us some information about how they're approaching and how they're architecting it. Because we've talked about some other, it's been a while. We've talked about some other like hypervisor and uh, host fuzzers and things like that. But nothing that quite worked in this way that I recall, or that had this sort of, I guess, framework to it, as they say.
It's funny because they basically discovered this issue by accident. They mentioned, I think it was in their slides, they mentioned that when they triggered this bug, they got excited because they were like, okay, we found a hypervisor bug. The whole idea here is they try to target everything that's relevant for hypervisors. So what ended up coming across this is they were fuzzing the page tables, and the page tables indirectly, well, pretty much directly actually, have an impact on the TLBs because page table entries um, are what gets cached into TLBs, right? And page tables are pretty relevant to virtualization because the guest has basically direct control over them. There is nested paging where the addresses will go through a secondary translation. So basically, what the kernel thinks is a physical address isn't a real physical address. It then gets translated again by the hypervisor. But for all intents and purposes, the guest page tables are what are directly going to the TLBs. So that's why they were able to trigger this bug from the guest and why they thought initially, like, hey, we got a hypervisor bug. Uh, it's pretty crazy to think that you were able to trigger a bug in the CPU itself. Um, Generally, you don't want to make that assumption. You want to really try to prove that the CPU is not the point of failure because very often it is not. It's like your last case scenario sort of thing. So it's funny that it seems like that is the case that's going on here. But as you mentioned earlier, there is a fair amount of speculation happening because when you get to the TLB level, it's just so undocumented and you're getting into like heavy trade secret type territory. So you have to speculate by necessity.
Yeah, still, I think like an interesting bug, interesting case. In the presentation, they also talk a little bit about trying to debug this, and I thought it was funny how, yeah, their case study here on trying to debug this thing is just like, yeah, host unresponsive, host crashes, and then they finally get a debuggable crash when they run Hyper-V under VMware. Except the crash that they got was a bug in VMware's nested virtualization. But the way they actually managed to debug it was by patching uh, the machine check air handler and the double fault handler so that they could basically keep things going.
Yeah, it's pretty funny.
Yeah, I mean, I thought the Hyper-V under VMware aspect giving them a different bug was the funny aspect of it.
Yeah, it's just when you're going to like virtualization, it's gets so complicated because you're factoring in different technologies that are in play. Uh, like the underlying virtualization technology implemented by AMD and Intel and whatnot is fairly consistent, but then you have to deal with how the virtualization is being done between the different hypervisors, and yeah, it like I said, it's a mess. You're the lower level you go, the harder it is, and the more complexity there is that's involved. So yeah, I appreciated this post, even though there's speculation and I don't follow it 100%. Um, it's still at a high level you're able to understand what the bug is and why it can be impactful. So as far as I know, though, I think this could only really lead to a crash. So it's a little bit like disappointing on that aspect, I guess. Maybe I'm wrong. It seems like their POC and everything obviously goes trigger a crash because that's an obvious side effect you can observe. But I believe what they're saying here is that because of the electrical corruption triggering the memory check exception, uh, this seems like it could only really be a DOS. But maybe I'm wrong on that. Although even still, when you're able to trigger a DOS on the host machine from the guest kernel, that is fairly significant, especially when you're talking about like cloud setups and whatnot. So I don't want to dismiss it out of hand, even if it is just a DOS. But I don't think you could do some of the attacks that you've seen in like speculative execution type issues.
Yeah, that was my reading too, was that this was a denial of service, but because this is a guest the host thing, like it still has a pretty fair impact. And especially because it's at the CPU level, uh, any guest like it doesn't even matter really what the like host VM or whatever is, it's just what's the host CPU.
Yeah, it's not something you can really mitigate. So
Yeah.
yeah. All right, so that's all the topics we have for this week. We do have some shoutouts. The first of which is from Hombre and is on fuzzer development. I had started reading this post. I haven't gotten all the way through it yet. It is a bit of a long one, but it talks about using Box, and it's funny. I saw some Twitter posts, and I think he said the most common question he gotten out of this post is how are you able to compile Box, because it's just such a it's kind of in that ecosystem where it's like it's open source and it's fun, but it's also really hard to compile, and, things like that. But yeah, I mean, Hombre's posts, like, they're always very interesting, and I think this takes some inspiration from some stuff that Gamozo Labs had done with
Yeah, he
fuzzing before.
mentions Gamozo Labs who, because I think he's writing the fuzzer in Rust also,
Yeah.
which is, Gamozo Labs had his series on, fuzzer development that was a Rust based fuzzer.
Yeah. So, you know, there's a lot of cool work being done on the fuzzer front by Gamozo Labs, and given that there's some inspiration from him, it's always fun to see some new things being explored on fuzzing. So definitely worth giving a read if you're into fuzzing. And then our second shout out is iLeakage. So this was a speculative execution type attack, specifically on Safari. Uh, and yeah, I believe it takes, yeah, it says here it takes advantage of Spectre. So um, you know, we don't really cover the speculative execution as much anymore on the podcast, partially because it's just a really difficult issue to cover. It's not very intuitive. So we wanted to mention that this was published. If you're into more of the hardware level stuff, you can go and read it. But we're not going to do a full coverage of it on the podcast.
Yeah,
It's kind of out of scope.
they have the paper there available if you're interested in what's novel about it, but it is another case of just being able to use that speculation and then finding that side channel, I believe, to leak that information. And they did kind of have the aspect they are doing this in the browser, which doesn't have like the really good timer access that you usually need for these. So
Not
there are some
anymore.
novelties to the attack. Uh, I just don't feel competent to cover it, even less so than the TLB thing we were talking about earlier.
Yeah. All right. So with that said, that's all the topics we have for this week. As always, thanks goes out to all of you for listening. If you want to go back and check out past episodes, you can find them on YouTube, Spotify, Apple Podcasts, and more links on Anchor. Feel free to join us on Discord and follow us on Twitter. Links to those are
So
down below or in the chat as well.
before we take off, actually, does remind me, we mentioned this on our bounty episode, but should maybe also bring it up here, which is we are thinking about moving to a uh more just recorded podcast format rather than doing these streams every week. We would just record when we're actually available to record and then put it out. So if you have any feedback, thoughts on whether or not we should or shouldn't move doing recorded only and drop these streams, perhaps I've thought about doing like a podcast prep stream as like I've thought about doing that in general, but as like a replacement where there's still something going on, but it's not like a proper podcast or just other streams maybe getting done. Honestly, probably unlikely that we'd start immediately doing a lot of streams, but we're thinking about making the change to the podcast itself. So if you have any opinions, feel free to reach out to us on Discord or emails on our website or whatever.
Yeah,
Comments.
Discord would probably be the best way to go about it. Would be it'd be the easiest to see it there. So
Yeah.
yeah, and as I said, Discord link for that is in the chat or down below. And yeah, fair shout. I'd kind of forgotten about that. And with that said, we'll see you next week.